So our next lesson, we are going to be converting between all the forms of quadratic equations and their graphs, and being able to graph them from all the forms. And the main task for you guys is to be able to convert between the forms effectively, not only algebraically, but also be able to graph between the forms as well. So the first form of a quadratic function that they teach you when you're younger is the standard form of a quadratic. They call it polynomial form in some books, but notice there's no parentheses. The squared quantity is the a term. So this is the normal form of a quadratic. And when we're graphing in what we usually refer to as standard form, you have a tiny formula that helps you find the axis of symmetry. So the axis of symmetry can be found by using the formula x equals negative b over 2a. So you might notice that's like the beginning of quadratic formula if you take off the plus and minus discriminant part. So that is the formula that helps you calculate the very center of your parabola, the line that splits the parabola in half. Now that is the center, which means that's also where the vertex is located. So when you go to find the vertex, you're going to use this formula here to find the x. And then once you know the x, you can plug it in to find the y and plug it into the formula. So that's where I'm going to start. We're going to calculate negative b over 2a for this question. So negative b would be opposite of negative 4, so positive 4. So x equals positive 4 over 2 times a, which would be 2 times 2. So 4 over 4 is a 1. Okay, pen, come on. So we just found a couple things. We found the axis of symmetry, which is important, but we also found the x-coordinate of your vertex. So the next thing I'd like to do is find the y-coordinate of the vertex. If I know x equals 1, go up to your formula and plug in x equals 1. So up here, you're plugging in 2 times 1 squared minus 4 times 1 minus 6. And what is that? 2 times 1. 2 minus 4 minus 6 is negative 8. So you just found the y-coordinate of your vertex. So if we were graphing this, I then would ask you to plot the vertex, and we're going to just kind of estimate this to be at 1, negative 8 down here. And this is where it kind of gets crazy, because now they're going to want some things from me. They're going to want the x-intercepts, and they're going to want the y-intercepts. So without a graphing calculator, this can get tricky. The x-intercepts are also known as the zeros of your parabola or your function. So if you had to find the x-intercepts without a graphing calculator, you have to know when the function equals 0, which means you have to factor and solve it. So good news, this does factor. Technically, I know it's scary because it's a y equals. You can technically divide the 2 out of it because I just need your solutions reduced. So if you thought of this as 1x squared minus 2x minus 3, that would factor into x minus 3 times x plus 1. And if you solved those factors, you'd get x equals 3 and x equals negative 1. So I found my factored solutions. Those are the x-intercepts. So for y-intercepts, a y-intercept for any function is when x equals 0. So all you need to do to find the y-intercept without a calculator is just plug in x equals 0. So if you go to your function, the original function, and you plug in a 0 here and here, you get 0 minus 6. So where is your y-intercept located? Negative 6. Oh my goodness. It's going to be one of these days where my pen doesn't work every third time. All right, here we go. So down here at negative 6 is where it would have crossed the y-axis, and now at this point I have enough information to graph my parabola, and you know I don't graph very well, so this is going to be a hoot. Here we go. Especially if my pen doesn't work. Come on, buddy. I'm going to call that a win. That's a pretty good parabola today. Alright, so we just did all of that without a calculator. So it's doable. It's not fun. And I know in Algebra 2, the first thing they had you do when you had to graph a parabola was grab your graphing calculator and program y equals and then get the stuff in, and you went to look at a table usually. So, but us being in PreCalc, we have to be a little more flexible than that because there will be times in our life where we can't use a calculator. So maybe write a few notes to yourself here, guys. How did we find the x-intercepts? We found the solutions, so we had to solve the quadratic. Technically, you could have used any method, but we chose factoring because that's a nice way to solve. All right, so the next form your algebra teacher taught you was called Vertex Form for most of your textbooks. It's also known as transformational form. We're going to have a big section of our next few units where we talk about transformations of functions. So those are referring to like the shifting right, shifting left, shifting up, shifting down, vertical stretches, reflections. So this is in a form where you can see all of those transformations. Anyone know off the top of their head what the x plus 5 transformation means? Is it right 5 or left 5? That's my question. It's left 5. Good. What does the transformation of a minus 4 off to the side do to a function? Yeah, I'm hearing it moves it down 4. And then for funsies, what if I throw a negative in front of a function? Reflects over the x-axis. And then do you remember what happens when the a value is a 3? What does it do specifically to your parabola? It makes it skinny. So this one's going to be reflected, but it's also going to be it's vertically stretched is the word. So it's been skinny. All right, so we have to find those same 3 things. That's a hoot. Well, the good news is vertex should be easy. Since it's vertex form, you should be able to tell me where the vertex is located. He's located at h, k. So right here in the formula, this is x minus h, isn't it? So who is h in your vertex? Negative 5. Very good. And then right here is k. So this is a negative 4. So your vertex is located at negative 5, negative 4. I'm just going to kind of pretend I know where that is. That wasn't a very good job, Abruzzo. We can go further over. Try that again. There we go. The intercepts. Basically, you need to find the solutions for x-intercepts. So you have to decide how you want to solve this function. I think this is a perfect function for solving by square rooting. Think of what would happen if you said, put a 0 here and I want to solve for this. You'd solve it by square rooting, wouldn't you? So I have a lot of room. You guys don't have as much room as me. I'm going to solve it. I'm going to start by adding the 4 over. And then we're not going to distribute that negative 3, right? We're going to divide by negative 3. And I will say, you guys did a fantastic job on that completing the square section. I know the fraction part was kind of weird, but in general, it's really good. Uh-oh, what's going to happen next, guys? I'm going to square root this. What happens when you square root any negative number? You're going to have an introduction of an I. So when you go to graph on the Cartesian coordinate plane, real numbers I can graph. Complex numbers, technically you can graph, we just haven't taught you how. The point is they're not the same place. So when I say what are the x-intercepts, if you know they're I solutions, you actually don't have any x-intercepts. That was a trick question. There are none. Okay, for the y-intercept, so here we had to find the solution for the x-intercept. For the y-intercept, you need to plug in a 0 for your x. So back to my function, if I plug in a 0 for my x, I get negative 3, 0 plus 5, quantity squared, minus 4. Oh boy. Okay. Negative 3 times this is 25, so that's negative 75, minus 4. Oh, good. Guys, I don't think we're going to have a lot of luck plotting a y-intercept at negative 79. So think about this. Just visualize. Your y-intercept is like, at the floor. So your parabola, since it doesn't have any x-intercepts, and we knew it was going downwards, and you already told me it was going to be skinny and reflected, so your parabola is looking something like this. Yeah, that's a really terrible sketch, but it gets the job done. If they want to know x-intercepts, y-intercepts, vertex, and general shape, we got it. Probably that parabola is much skinnier than I drew, but I can't draw very well, so sorry. Okay, one more form. This is called x-intercept form or factored form. So this is one of those moments in math where you're like, why did they call it x-intercept form? Because you can see the x-intercepts. It's already factored. So if you were to solve, now the half is doing nothing, so it can just divide out. But the two solutions that you get are your two x-intercepts. So we get x equals 5 and x equals negative 3. So I'm going to just kind of pretend I know where those are located. The y-intercept is always found the same way. You figure out what happens when x is 0. So if you were to plug in x equals 0 into your original function, you still have the 1/2 here in this case. So you have 1/2 and then 0 minus 5 times 0 plus 3. Let's see, that's negative 16 times half, so negative 7.5. I don't know, I'm kind of pretending I know where that is. If I ever have you graph these on a summative, I will give you a labeled coordinate plane, so there won't be any guessing. Now, guys, this is not the vertex, because I know the vertex is the dead center point, as the axis of symmetry goes through the vertex. And I can tell visually, even with my bad drawing, I haven't quite hit the vertex. So the vertex has to be in the middle of your parabola. Your x-intercepts are always symmetrically placed about the axis of symmetry. So what you need to do for the vertex, for the x-coordinate of the vertex, you need to find the midpoint of your zeros. So for us, the midpoint of negative 3 and 5 would be 1, wouldn't it? So I know here at x equals 1, my vertex is somewhere along this line. In order to figure out how far up and down that line is, I'm going to have to plug that in. So we're going to go to our function, which is this guy, remember? We're plugging in x equals 1. So 1/2 times 1 minus 5 times 1 plus 3. Whoops, another color. Okay, negative 4 times 4 is negative 16 times half. Is that negative 8? All right, good news. So at 1, negative 8, somewhere right here, that is the center of your parabola. That's your vertex. So, okay, missed. And again, my graphs are never really that great, especially when they don't have like labeled axes. That doesn't help me any. But if I kind of go back and look at that function, the a value of that parabola was a 1/2, which told me the parabola was going to be a little wider than a typical parabola. And again, I don't have units on my axes, but it does look a little wider than normal, but that might just be my graphing. Does yours look appropriate? And then we should see the x-intercepts at 5 and negative 3. Finding the vertex on that form is a little tricky, but if you understand all the components of the formula, you can transfer between them pretty easily. All right. This is going to be fun. This is all algebra here, guys. We're going to change between the forms. So I have a standard form parabola right now, and I want to write it in x-intercept form. So remember, the other form, the other name for x-intercept form was factored form. So a good algebra technique would be to factor. So you're not going to solve. You're just going to rewrite it in that exact form. So a little factoring here. Negative x minus 5 and x minus 1. Would that work? Boom. You got it. Intercept form. Now, it didn't go on and say, like, now find all that stuff. They're just having you transfer between the forms. So here we have another standard form, and I want you to write it in vertex form. There are two approaches. I'm going to show you the completing the square approach first, and I'm going to come back with another approach after that. And it's up to you which one you want to take. It depends on how crafty you are with completing the square. I'm going to call it completing the square, guys, but it's really a modified completing the square because I'm not going to let you do any work over here on the left-hand side of the equation. You're going to do all your work on the right-hand side. So, what you're going to do first, check that the coefficient's a 1. It is. Keep the quadratic and the x part, the linear part, keep it as it is. But here I want you to add a blank, because you are going to complete the square on this quadratic. But remember how there was already a +1? Typically when we were solving, we moved that 1 out of there. We're still going to move them, but not from that side, because I'm not allowed to touch the other side. So just kind of shove the +1 off to the side over here. But I have really messed up my equation. Like, I'm about to add a number right here. I got to keep it balanced. Anyone have a technique that would help me keep this balanced? Yes, Jen. Subtract the blank. So that's a little different than what we had been doing. We were working on opposite sides of the equation before, but now we're all on one side. So if you add 4, which we're about to do, and then later on subtract 4, you're still balanced. You're still the same equation. So you're going to use that same formula for completing the square. You take half of this number, cut it in half, and then square it. So we do get a 4. And then over here, a -4. And when this is taught to Algebra 2 kids, they're like, wait a minute, what? Like, why would you add 4 and subtract 4? This is where math gets crazy. You can selectively group terms. So I want you to group this quadratic and think about how you could rewrite x squared minus 4x plus 4. Because the reason we completed the square is so we could rewrite it into x minus 2 quantity squared. And then over here, you had that existing 1, and then we fixed our work by subtracting a 4. 1 minus 4, better known as negative 3. Ladies and gentlemen, you have vertex form. I kind of like that technique. I think it's neat. The next one, we're going to do the same technique, but does anyone notice a problem with completing the square on something that has 2x squared? The very first rule of completing the square is it doesn't work unless your first coefficient is a 1. Now, if this was a solving question, I'm allowed to use each side of the equation. I just divide that 2 out of there. I'm not allowed to touch the other side of the equation, so you can't do that. So, I'm going to move my work down here. Y equals, instead of dividing it out of the equation entirely, what you're going to do is you're going to take the first 2 terms of the existing quadratic. You're going to factor the 2 out of them. So the 2 comes out of those first 2 terms, and then leave kind of a bigger space of parentheses here. What is left from these first 2 terms if you took the 2 out? You still have x squared, and you still have a minus 6x. We are going to complete the square on that little baby quadratic. Close your parenthesis, because that's its own little problem. I already had this plus 7 off to the side. I just kind of shuffled him along. But I've really messed my math up here, guys. I'm going to add something, and then in order to balance it back out, since I'm on the same side, I'm also going to subtract something. Okay. What goes in this blank right here? Half of your b terms squared. So negative 3 squared would be a 9. But be careful. What did you really add to that problem? Is it a 9? It's really an 18. See that? So when I balance this out, I actually have to subtract 18 right there. That was crafty. So the 2 stays. That's not exciting. But I need you to rewrite x squared minus 6x plus 9 in its factored form. So that'd be x minus 3 quantity squared. And then plus 7 minus 18, better known as negative 11. Or subtracting 11. Boom, vertex form. Okay. Let me see what's coming up next. I'm going to do... We're going to jump ahead, actually, if you don't mind, to letter D at the bottom of the page. Do you see letter D? It says g of x equals. Just because we're going to stick with going to vertex form, I'm going to show you the other method for going to vertex form that does not involve completing the square. Some kids do not really enjoy completing the square on a good day, and they really don't enjoy it when there's a coefficient of 2, or 3 or 4. So I'm going to show you another method. For part D, if I need to write this, what do they want me to do? They want me to find the vertex. You know, just for funsies, say I want you to get it in vertex form. Instead of completing the square, there's some directions there. It says you can actually find the vertex using that little vertex formula. So remember at the top of standard form, at the beginning of the notes, we said the axis of symmetry is negative b over 2a, and that's going to be the x-coordinate of your vertex. So let's go ahead and do that. So negative b would be negative 18 over 2 times negative 3. So negative 18 over negative 6 is 3. So you guys just found the x-coordinate of your vertex. It is 3, comma, let's find the next part. So go back to your function. And you're going to need to plug in a 3 for all those x's. So negative 3 times 3 squared plus 18 times 3 minus 1. Oh gosh. All right. 9 times negative 3 is negative 27. Is that plus 54 minus 1? You should probably check my math there, guys. When you add that, is it 26? Okay. So you just calculated the y-coordinate of the vertex. So if I think about vertex form, it's, oops, not y. G of x equals. Remember, it's a times x minus h squared plus k. Guys, I think you know all the pieces. Like, for instance, did anyone figure out what a was? It's the same a in every form. Who is a for this problem? Negative 3, yes. And then you just found your vertex. So when it says x minus h, who was the h coordinate that you just calculated? This 3, yes. And then plus k, who was the k that you just calculated? At 26. So this parabola in vertex form is -3. Oops, what did I forget? Silly me. I do this every time. Isn't there supposed to be a squared somewhere in this problem? It's x minus 3 quantity squared. Alright, so this parabola in vertex form is -3 x minus 3 squared plus 26. We could have done that with completing the square like we did up here in these examples. It is completely up to you how you find the vertex and how you get it that way. Me personally, I don't know if it's just the way I was taught originally and I just stuck with it. I always do completing the square. I just find it easier because I really like completing the square. But it's up to you. Alright, let's back up a little bit. We'll come back to finish up problem letter D because we haven't actually finished it. They want us to identify the vertex, the line of symmetry, and the direction in which it is opening. So this quadratic is already in vertex form. So telling you the vertex, that should be a really easy task. Where's the vertex located? Anybody? +5, 6. And then they also want the axis of symmetry, so I'm going to abbreviate that A of S. The axis of symmetry is the line that cuts through your vertex. So it's x equals, and then it's always x equals h, so x equals 5. And then I want to know if this parabola opens up or down. So since the a value is positive, it's going to open upwards. And then just for bonus points, would you consider this a normal parabola, a skinnier parabola, or a wider parabola? Well, skinnier than normal. Yep, that too makes it vertically stretched. All right, so letter B, same idea. It's already in vertex form, so that's exciting. Vertex form is telling you the vertex. Who is your h? -3, good call. It's the opposite of this sign. And then comma 7. So that means our axis of symmetry is the line x equals -3. It's always this. And this parabola has an a value of -3. So does this open up or down? Opens down. And I'm also going to ask you for fun, normal, wide, or skinny? Skinny, yeah. The 3 stretches it. Okay, part C. We are not in vertex form. So if I ask you to find the vertex, you have a choice to make. Would you like to complete the square? Would you like to find the vertex using -b over 2a? Since he's the only one who talked, I'm going to go with that method. Speak up, children, if you really love complete. Now, if you want to move ahead and do completing the square on your own, go ahead. We do have 2 examples at the top where you can refer back to that. All right, I'm going to go with it. So we're going to use this formula to find the x-coordinate of our vertex. So opposite of b would be +6 over 2 times a. Ew. So 6 over 4 is 3 over 2 when you reduce it. You can call that 1.5 if you'd like. I'm going to leave it as 3 over 2. So your vertex, I know the x-coordinate is 3 over 2. What do I have to do to find the y-coordinate? Plug it in. All right, here we go. Since y'all love to work with fractions, 2 times 3 over 2 squared minus 6 times 3 over 2 plus 13. Okie dokie, kids. Squaring a fraction, you square the numerator and denominator, so that's a 9/4, right? So this is 2 times 9/4 minus, guys, when you multiply fractions, you can just multiply across the numerator and denominator and then simplify, or you can cross cancel. So most kids like to cross cancel. They'd call 6 and 2, they'd cut this down to a 3. Either way, this comes out to a 9, because at some point you will reduce to a 9. So here, hey, Mrs. Hoffbauer. So multiplying 2 times 9/4, that's 18/4, which will reduce to a 9 over 2. Oh, gross. All right, 9 over 2 minus 9 plus 13. Okay, I'm going to go to fraction land. This is 4.5. So -9 plus 13 is 4. 4 plus 4.5 is 8.5. All right, here we go. So you can call it 8.5, or you could call that 17 over 2. Thank you. Oops, that was plus 4. And just for fun, it opens what direction? Up. And is it regular, thin, or wide? A little thin. 2 makes it vertically stretched. All right. That was probably a good choice on that method, John, because completing the square with fractions would have not been my favorite moment. So, thank you. Let's skip to the back. Don't cross off C. We're gonna come back to C on Tuesday. Because, you know, after a long weekend, enjoying yourself, what a better way to start your week than that. Okay, these are fun. We're gonna find the equation of the parabola. And the suggestion is that you start with vertex form, and then you find a point, and then you do some work and solve. So these are going to be kind of tricky. And what's going to happen is when I ever give you homework on this or test you on this, I'm not going to make you estimate anything. I'm going to actually give you labeled points, because this would be very difficult to do without me just flat out telling you the ordered pairs. So I'm actually going to flat out tell you where the vertex is located. It is at the ordered pair 2, 1. And maybe you thought it was at 2, 1 from the picture, but if not, I'm telling you, it's at 2, 1. And then the other thing I would give you is I would give you a little hint that it also goes through the ordered pair 1, 2. So you have to think about what those clues mean. The vertex, while it is an XY ordered pair, what the vertex really is H and K. And then the other ordered pair I gave you is just some random ordered pair X and Y. So what we're going to do is we're going to start by thinking about vertex form, which is Y equals A, X minus H quantity squared, plus K. You guys know 4 pieces of information. You know H, K, X, and Y. Put them where they belong. So what was the Y coordinate of that random point I gave you? 2. I do not know A, so leave it as a variable. What is the X coordinate of that random point I gave you? This 1 right here. Minus. Who is the H? It's 2. I don't like this problem because there's a lot of 1s and 2s and it's really confusing. So that's why I'm doing mine color-coded. So if you ever look back at the slide, then you'll figure out where the 1s and 2s came from. All right, this quantity is going to be squared, and then you're going to add to that the K value. Who is the K value from the vertex? That's a 1. All right, here it goes, guys. We got to simplify this. So 2 is 2. I'm not going to do anything there. Leave the A in front. But this quantity right here, this is -1 squared, which means it's just a 1. Okay, guys, I need you to solve for A. So you're going to subtract 1 over. And then normally I'd tell you to divide by the number in front of A, but it's just a 1. So 1 equals A. This is the stuff that kids don't like because they're like, well, I kind of thought A was 1, but you can't just assume A is 1 if it looks normal, because I'm going to give you really tricky ones on a test where A is something weird and you're not going to guess it. So you have to do the math. So guys, we're actually not done because the whole point of this question was you need to write it in vertex form. You were almost there. You had H and K, but now we know A. So your final answer is, go back to variables for Y and X. Y equals, you can put a 1 if you want, but then it's X minus H, so X minus 2 squared plus K, which is 1. So that green clue at the beginning, that random ordered pair they gave you, you're just using that to find A, and then once you get that out of the way, you just throw that point away. You don't need it anymore. All right, this next one. I'm going to tell you that the vertex is located at -2, 3. And then I'm going to randomly give you this ordered pair. Ready? Let's color code this again, same way. I'm going to randomly give you the ordered pair. This intercept right here is at -1, 0. Okay. So the vertex is the H and the K. The random ordered pair is the X and Y. Let's use those clues and let's plug in. Here we go. So who's the Y coordinate of the random point I gave you? Of the Y coordinate of the random point is 0, isn't it? 0 equals, I don't know A yet. Who's the X coordinate of the random point I gave you? That's -1. And then we're supposed to subtract the H. Who is H? It's -2, isn't it? So we're going to do that double slash thing. And then we're going to square that quantity. And then plus, who is K? 3. There we go. All right, here we go, guys. We got to do a little algebra now. So 0 equals, leave A for a moment. Right here, -1 plus 2, that's boring, that's a 1. 1 squared is 1. plus 3. Subtract 3 over, normally we'd say divide by what's in front of a, but it's just a 1. So it turns out a equals negative 3. Again, I know you might have been able to guess your way to that or assume it was negative 3 because of the picture, but I don't know, I wouldn't have assumed that was negative 3. So you have to show me the work of finding it. It's going to be weird. So y equals negative 3. And then go back and use your h and k. So x plus 2 squared plus 3. Alright. Let's get let's go ahead and get C done. So I'm going to tell you that you have a vertex right here at negative 2, negative 2. And then the random point I'm going to tell you is that it definitely goes through this ordered pair right here, 0, 0. So the vertex, oops, not that. The vertex is H and K. I suggest you label it so. The ordered pair is X and Y. Here we go. Remember, you're using this form. So who's the y coordinate of the random point I gave you? 0. I don't know A yet. Leave it. Who's the x coordinate of the random point I gave you? Also 0. Minus, who's h? Negative 2. So do that double slash thing. And then you're supposed to be like adding a k. But who's k? Negative 2. I'm just going to change that to a negative 2 if you don't mind. Okay. Be careful on this part, guys, because this kept coming out to a 1 in the previous questions. This is not a 1 anymore. So you have 2. Remember, you're squaring this quantity. So what's truly the number attached to a? It's really a 4. Yeah. So 0 equals a times 4 minus 2. Let's please solve. You're going to add the 2 over. So you can write that as 4a, can't you? And then when you divide by 4, you just found out that that a value is a 1/2. So now when you go to write the formula, you go back to this. You have a and h and k that you plug in. So formula is y equals 1/2 x plus 2 squared minus 2. These are tough. These are probably the, in my opinion, the most difficult thing in the next couple days. Alright, so here's what you got to do for me. On worksheet 7. We're not assigned the whole worksheet, so let's first figure out what we're assigned. Is it circled on your worksheet at all? Yeah. It is? No. Oh, no. Does anyone have that blue sheet handy? Because I don't want to do extra work here, guys. Okay, so on worksheet 7, you're not ready to do the whole worksheet, guys, but you will be assigned numbers 1, 6, 9, 11, 13, 15, and 17. So you might have to just do part of it for now until we learn the rest of the lesson. But those are the problems you will be assigned. Alright, signing off.